In the vast theater of the cosmos, where silence reigns yet violence hides in every shadow, two titans emerge. On one side, black holes, mysterious, relentless, insatiable voids that devour everything, even light itself. On the other side, neutron stars, the densest objects in the visible universe, tiny yet unimaginably powerful, matter crushed to the edge of physical possibility, both born from death, both forged in the fiery collapse of massive stars, both pushing the limits of physics to extremes. But which one is truly supreme? Which one holds the ultimate power in this cosmic battlefield? Tonight we enter the ultimate showdown, black holes versus neutron stars. Every showdown begins with an origin story. And for both of these cosmic beasts, it starts with the death of a star. A massive star lives fast, burns hot, and dies violently. When its nuclear fuel runs out, gravity takes over. The star's core collapses. Its outer layers explode outward in a brilliant supernova. But what remains at the core determines the star's afterlife. If the star's core is between 1.4 and 3 times the mass of the Sun, it collapses into a neutron star. If the core is heavier still, gravity overwhelms every known force, and the star collapses into a black hole. So, from the very moment of their creation, a delicate cosmic balance decides the outcome. But the story doesn't end there. It only begins. Imagine compressing the mass of our Sun into a sphere just 20 kilometers across. That is a neutron star. A teaspoon of its matter would weigh 1 billion tons. Its surface gravity? 200 billion times stronger than Earth's. Atoms cannot exist there. Electrons and protons are crushed together to form neutrons, the building blocks of nuclear matter. But the extremes don't stop there. Neutron stars often spin at incredible speeds. Some rotate hundreds of times per second. These are known as pulsars, cosmic lighthouses that beam radiation across the galaxy. Their magnetic fields are trillions of times stronger than Earth's. A field so intense it could erase every credit card on Earth, from half the distance to the moon. Neutron stars are tiny, but terrifying. They are the definition of concentrated power. Now imagine collapsing the same stellar core, but this time, gravity wins completely. No pressure, no force, no quantum resistance can stop it. The core collapses into a singularity, a point of infinite density, surrounded by an invisible boundary, the event horizon. Cross it, and nothing escapes. Not matter, not radiation, not even light. This is a black hole, but black holes come in many sizes. Stellar black holes weigh a few times the mass of our Sun. Supermassive black holes, billions of times heavier, anchor the hearts of galaxies. Black holes don't just sit still. They grow. They devour stars. They merge with other black holes. They warp space and time itself. If neutron stars are extremists, black holes are conquerors. Silent, relentless, absolute. Here lies the first battlefield of our showdown, density versus gravity. Neutron stars are the densest stable matter in the universe. Their crust is harder than any material on Earth. Their interior is a soup of neutrons, perhaps even stranger particles like quarks. But density alone is not destiny. Black holes are not dense in the same sense. Their power comes from pure gravity. The event horizon is not a surface of matter, it's a point of no return. Step inside, and the laws of physics unravel. So, who wins this round? Neutron stars win on density, but black holes win on gravity. It's a draw, and the battle rages on. Both neutron stars and black holes release astonishing amounts of energy. A spinning neutron star emits beams of electromagnetic radiation. Pulsars can outshine entire galaxies in radio waves. Some neutron stars, called magnetars, unleash magnetic storms so violent they can disrupt satellites on Earth from thousands of light years away. But black holes are no slouches. When matter falls toward a black hole, it heats up in the accretion disk. Temperatures soar to millions of degrees. jets of energy blast out at nearly the speed of light. These jets can stretch across entire galaxies. So, who claims this round? For raw, focused energy bursts, neutron stars dominate. But for colossal, universe-shaping power, black holes rule. What happens when these titans collide? Two neutron stars spiraling together create one of the most violent events in the cosmos. They merge, releasing gravitational waves that ripple across space-time. The collision also forges heavy elements: gold, platinum, uranium. Every ring on your finger was likely born in such a collision, but black hole mergers are even more ferocious. When two black holes unite, they send out gravitational waves with more energy than all the stars in the visible universe combined, for a fraction of a second. And what happens when a black hole meets a neutron star? The black hole almost always wins. The neutron star is ripped apart, shredded, and consumed. Its matter swirls into the black hole's maw, leaving nothing behind but silence. Here, the victor is clear. Black holes reign supreme. Neutron stars push physics to its limits. They test our understanding of nuclear matter. Are they made only of neutrons? Do they hide exotic states of quark matter? Do they hold the secret to unifying the forces of nature? But black holes break the very rules. Inside the singularity, general relativity collapses. Space and time lose meaning. Cause and effect may no longer exist. Physicists believe quantum mechanics must have an answer, but so far, the mystery remains. So, in this chapter, the black hole claims the throne, because it forces us to question reality itself. Here's where the showdown turns philosophical. Neutron stars are strange, but mortal. Over billions of years, they cool, they fade, they become cold, dark relics of once mighty stars. But black holes are immortal, almost. Thanks to Stephen Hawking, we know they evaporate. Through Hawking radiation, black holes slowly lose mass. But for a stellar black hole, the process takes longer than the age of the universe. For supermassive black holes, the process takes a number so large it's beyond imagination. In the far future, long after the last stars burn out, black holes will remain, the last titans standing. In the battle for eternity, black holes win. So now we face the final question. Black holes or neutron stars? Who is the ultimate victor? Neutron stars are marvels of matter. They are dense, fast, magnetic, and furious. They sculpt the universe with bursts of energy. They are living laboratories for the laws of physics. But black holes are the end game. They are destruction incarnate. They warp reality. They shape galaxies. They consume neutron stars as prey. They dominate the universe's final act. So, the crown must go to the black hole. Not because it is more elegant, but because it is absolute. It does not compromise. It does not yield. The black hole is the ultimate cosmic champion. Yet, this battle is not just about who wins. It is about what these titans teach us. Neutron stars reveal the mysteries of matter under pressure. They may show us the secrets of quantum mechanics, nuclear physics, even the birth of the elements themselves. Black holes force us to confront the edge of knowledge. They hold the key to unifying relativity and quantum theory. They may hide portals to other universes, or the truth about time itself. Both are not enemies, they are teachers. They are signposts on our journey to understand the cosmos. And as we watch them dance, collide, and dominate the night sky, we are reminded of one truth. The universe is not quiet. It is alive with extremes. It is alive with battles beyond imagination. And we are lucky enough to witness them. So when you look up at the night sky, remember this. Every twinkling star you see may one day collapse. Some will leave behind a neutron star. Others will vanish into a black hole. Both outcomes are testaments to the raw power of nature. Both remind us that we live in a universe where giants clash, where mysteries linger, and where the ultimate showdown never truly ends. Because in the cosmos, there is always another battle waiting. Black holes, neutron stars, two titans, one universe, and a never-ending story.